All right, we are going to continue with some more transformations of our sinusoids. Last class, we talked about changing the amplitude, the period, and reflections. We're going to dive straight in. C. C is the value that's added or subtracted in with the x inside the sine or cosine. C is called the phase shift. It moves our starting point left and right. Normally, sine starts at 0, 0. A C value shifts it to C, 0. Cosine is very similar, except it's C, 1. D. D is our vertical shift. D is added or subtracted. It might be in the front or the back, so be careful. D could be either of those spots. It's the value added or subtracted outside of the sine and cosine. It moves it up and down. And remember, phase shifts are opposite of what they seem. Vertical shifts are exactly what they seem. So, amplitude, period, phase shift, and vertical shift now, adding it all together. Amplitude is still that number out front. That is 2. Period is still the number multiplied by the x, 2 pi over that, which is just 2 pi. Phase shift is any number added or subtracted in with the x. So that's a pi. Since it's minus, it's pi to the right. And vertical shift, any number added or subtracted outside. For phase shift and vertical shift, there can be none. None is an acceptable answer. Amplitude, period, phase shift, and vertical shift of this one. Amplitude is the number out front, that is 4. Period is 2 pi over the number multiplied with the x, which is just 2 pi. Phase shift is the number in with the x, which is pi over 4. The plus means that it is to the left. And the vertical shift is the number added or subtracted outside. That's this 2. It's a minus, so it is down. Amplitude, period, phase shift, and vertical shift of this one. We start with the amplitude. The number in front is 3.5. It's important to note here, that's also a reflection over the x-axis. That's not always in my question, but it's important. Now, anytime we have a b value, we might have to do some extra work. If there is a phase shift and the b value is not factored out, you need to factor it out. So we are going to rewrite this as negative 3.5 sine of 2 times x minus something, minus 1. Now 2 times what makes pi over 2? Pi over 4. Basically, we divided the 2 back out. This way, we can do our phase shift, vertical shift, all that fun stuff in the same order every single time. So our period is 2 pi over 2, which is just pi. Our phase shift is actually pi over 4 to the right. And our vertical shift is 1 down. So you have to be really careful. If that b value is not factored out, make sure you factor it out. And same thing again. Our amplitude here is 4, that number out front. Our period, well, we see x over 2, it's not factored out, so we have 4 cosine. We're going to factor out a 1/2. X minus 1/2 times what makes just pi? 2 pi. There we go. So our period is 2 pi over 1/2, which is 4 pi. This one is wider, it repeats less often. Our phase shift is that 2 pi. It's subtracted, so it's to the right. Vertical shift, there was no number added or subtracted outside, so none. So let's try a little graphing with everything. Start by stating all these important features of your graph. Let's shift this over just a little bit. All right, our amplitude is 2. This negative makes it a reflection over the x-axis. The period is 2 pi over 2, so pi. There's no phase shift. And the vertical shift is 3. That 3 is positive, so it's 3 up. Notice that with the vertical shift in the front, the minus stays with the 2. because I could have rewritten this as negative 2 cosine of 2x plus 3. All right? So I like to start with my vertical shift. I shifted 3 up. So I draw myself a solid line for my vertical shift. All right? Graph that first. Then I deal with my amplitude. My amplitude's 2. That means from this line, I go 2 above and 2 below. So I'll go down to 1, up to 5, which goes off my graph, my bad. All right, so that's the second thing I do. Then I worry about a phase shift. No phase shift means that the y-axis is still my starting spot. And then the period. The period is pi, which means from 0 to pi, I'm going to get 1 full period of my graph. So there's 4. Oh, 4. The reflection is the last thing I deal with. It's step 5. I just draw that in as I graph. Cosine. Cosine usually starts at 1, ends at 1, middle at negative 1. Reflected means that it'll start at the bottom, end at the bottom, middle at the top. The bottom is just this lower dotted line. The start is 0. The end is where I said this 1 period ends. The middle, right in the middle, up at my top line. The middle now, instead of 0, it's going to be this solid line that I drew from my vertical shift. And then I follow my pattern. Essentially, I'm going to draw in a new x and y axis for myself to use. And this side, following my pattern, up, down, and connect it. And there's our graph. Next one. All right, so we start off with our amplitude. The amplitude is the number in front, that is 2. The period is 2 pi over 1/2, which makes it 4 pi. The phase shift is pi to the right. And the vertical shift is 3. It's got a minus on the 3, so it's 3 down. So I would start off by drawing in my vertical shift. 3 down. All right, that means negative 3 is my new x-axis. I'm going to ignore the x-axis now. It doesn't exist to me anymore. So first thing, vertical shift. Second thing I worry about is my amplitude. It goes 2 above and 2 below that new x-axis. I give myself dotted lines at negative 1 and at negative 5, which is just off of my graph. All right, then I deal with my phase shift. My phase shift is pi to the right. So at pi to the right, I make myself a new y-axis, essentially. So now instead of using the origin for anything, I'm going to use this point, pi negative 3, as my new origin. And then fourth thing is my period, 4 pi. So if one period starts at pi, then it ends at 5 pi. I like to make myself a little markup here. Okay, that's going to be 1 period. Maybe I'll bring it down too. That helps me too. All right, I don't have any reflections. So now I say, all right, I'm dealing with sine. Sine starts at 0, ends at 0, middle at 0. My start is now this point, pi, negative 3. My end is 5 pi, negative 3. My middle then is 3 pi, which is also 0. Sine starts at 0 and goes up, so it goes up to its maximum, down to its minimum, and then I follow my same pattern over here. And I have the graph of my transformed sine function. All right, this one gets a little complicated because you'll notice the b value is not factored out. So we want to rewrite it right away. Negative 2 minus the cosine of 1/2 times x plus pi. Because 1/2 times pi makes pi over 2. So the amplitude is 1. Remember, amplitude can never be none. If there's nothing in front of cosine, it's the invisible 1. But we do have a reflection over the x-axis. That's what that negative tells us. The period is 2 pi over 1/2, which is 4 pi. The phase shift is pi to the left. And vertical shift, we have a shift of 2 down. All right, start my graph with my vertical shift 2 down. Then I draw in my amplitudes, 1 and -1, 1 above, 1 below. So we go from a max of -1 to a minimum of -3. All right, we had a pi left phase shift, so I'll draw on my new y-axis. And my period is 4 pi, so I'm going to mark that out. 4 pi would take me to pi over 3. There's 1 period. Give myself a dotted line over there. And we have a reflection over the x-axis. So I keep that in mind. Different color. Cosine usually starts at the top, ends at the top, middle at the bottom. But if we're reflected over the x-axis, we start at the bottom, end at the bottom, middle at the top, and right in between any of those are our centers. And continue my pattern. Oops, that should be there. And there's our graph. One other thing we're going to do is to construct a sinusoid with the given amplitude and period that goes through the given point. So I'm going to write the equation of something using sine or cosine. Well, if the amplitude is 2, I know A must be 2. The period is 3 pi. 3 pi is 2 pi over B. So this will help me figure out what B should be. I multiply my B over. B times 3 pi equals 2 pi. Divide by 3 pi. B is 2/3. And then this point, 0, 0. There are many, many, many correct answers to this. I personally say 0, 0, well, that tells me I should use sine. Because 0, 0 is on the graph of sine usually. So we just plug in y equals, our A value is 2, sine of 2/3 x. And there we go, that one works. There are also other options, all right? I could have used a cosine and had a phase shift. I could have a negative in it somewhere. All right, amplitude is 3.2, the period is pi over 7, it goes through the point 50. Amplitude is pretty straightforward, the amplitude is 3.2. Period is not too bad, pi over 7 equals 2 pi over b. Multiply my b over. B times pi over 7 equals 2 pi. Multiply by 7 over pi. My pi's cancel. B is 14. 50. Many ways I can do this. All right. I know usually sine has 0, 0. And cosine has 0, 1. So I would go with a sine and a phase shift of 5 right. That's probably how I would go about it. So my y equals 3.2 times sine of 14 times x minus 5. Usually our phase shifts have a pi in them. This one doesn't. It looks weird, but it works. So a little summary here. C value. We might use different letters for these, all right? The number that's added or subtracted in the front or the back, that is your vertical shift. A in the front, multiplied by it, that is your amplitude. And it's a reflection over the x-axis if it's negative. B tells your period. And remember, period is 2 pi over the absolute value of B. This is a reflection over the y-axis if it's negative. And D is your phase shift in this. That scoots it left or right. Finally, we're going to talk about how to check your graph with a calculator. So, we're going to be graphing in radian mode. So always go mode, make sure you are in radians there. I am, I'm good. We're going to enter the function in the y equals screen. So y equals, oh, don't need those. Let's try sine of x. Close my parenthesis. Then we change our window. So go to window, x min, make it negative 2 pi. X max, 2 pi. Notice that your calculator might change those to decimals right away. X scale, pi over 4. Pi divided by 4. Boom. Y min, negative 1. Y max, 1. Y scale, let's go, 0.25. And then graph. And now I have my graph. I can also say, all right, how about if I make this one cosine of x? And look at that. If I wanted to double check a graph that I made earlier, flip back to one of these. Let's say I want to double check my negative 3 plus 2 sine 0.5 times x minus pi. All right, you'll notice when I graph it, it doesn't show me anything. But when we graphed it, remember that our minimums were at negative 5, our maximums were at negative 1. This graph is set up from negative 1 to positive 1. We gotta change our window. Our y min, let's make it negative 5. Now I see original sine, original cosine, and there is my transformed graph. It's only showing me negative 2 pi to positive 2 pi. So if I compare just that portion of the graph I drew, it looks pretty darn good to me. So your assignment is going to be a worksheet on all stuff graphing trig.